example, they've given us a formula, a is equal to 4 pi r squared, and they want us to isolate for r. So the trick to this is knowing what you have to undo first. So r is clearly not by itself. It's got 4 pi next to it. It's got a squared on it. We need to get r by itself. So do we undo the squared first, or do we undo the 4 pi first? And the wisdom comes in knowing that you should undo 4 pi first. So we are going to divide both sides by 4 pi. So then you have r squared is equal to a over 4 pi. But r is still not isolated because of the squared. So then you have to square root the both sides, like so. So your final answer is r is equal to the square root of a over 4 pi. And that's your isolation. We did that. So if a is 10, then what is the value of r? So all we got to do is plug in 10 for r, and we can, in theory, come up with our answer. The tricky part is typing this into your calculator. I believe that my preference would be to type in the inside first and then to square root the answer. But the key is, if you don't put the 4 pi in brackets, you're going to get the wrong answer. So what I just wanted to show everybody was how I typed this in my Casio in order to get it correct. So I actually typed 10 divided by 4 pi in brackets, and then I got 0.79577. And if you wanted, you could type that in and square root it. Like, that's not the answer, that's r squared. So you still have to square root that thing. If you want to square root in a Casio, you have to hit shift and then this button here, and that will hit square root. But if you don't want to have to type in the answer that you just got, you can hit shift and then this button here that has answer, and it will type in the answer, which means that it'll automatically input the answer that you just got. And if you do that, then the final answer to the nearest hundredth is 0.89. And I really like that answer function, because then if you find something here, you can just immediately plug it in there. So if we are trying to isolate for h in this case, look at all the stuff that's in the way, all this stuff. But student said, let's just kill off the 3 first, because I don't want to have to deal with fractions. So then your 3v is pi r squared h. And most of you would be able to tell me that we can take pi r squared and have our h equal 3v over pi r squared. Now, I'm pretty sure you guys were all able to do that for Math 15. But what about the part where we have to plug this in? So calculate h to the nearest 10th if we're doing it like this. If you type this in correctly, that means you have to put brackets around the denominator, otherwise it's going to come out wrong. You are going to get this out of your calculator, 7, 6, 3, 9, and etc. It keeps going. They want you to round it to the nearest 10th, which means to 1 decimal place. So we're looking at 7. But because its neighbor is 6, if the neighbor is 5 or higher, you have to round this out. This should be 0.8. If you put 0.7, you will not get part marks. It has to be rounded correctly. This is where formula manipulation gets a little bit uglier, when there's more than one term. And there are 2 terms here. So there's the clunky way, which will work. And then there's the ninja way. So I'll show you 2 different ways to do this. If we're trying to isolate h, we need to get rid of this first. Why? Because this one's further away. We'll get rid of the 2 pi later. So what you could do first is you could subtract this entire term from both sides to make it disappear. But you're not dividing by it, we're subtracting it, because this is like addition, 2 pi r squared. So we have this. A is equal to, or a minus 2 pi r squared is equal to 2 pi h. And then you can divide both sides by 2 pi to get this. A minus 2 pi r squared over 2 pi is equal to h. So that is correct, and you can leave it that way. But I want to show you another way. Let's start with the original again. A is equal to 2 pi r squared plus 2 pi h. Now, a lot of students recognize that these 2 terms are almost the same. They're very, very similar because they both have a 2 pi in them. So if you're feeling like a ninja, you can factor out the 2 pi. GCF factoring, like so. You can divide both sides by 2 pi. like so. And then you can subtract the r squared from both sides. So this is also correct, but it doesn't look the same as this one up here. But they are, in fact, equivalent. If you try to get these into one fraction by creating a common denominator, you could take this green one and make it look like this purple one. And they are exactly the same thing. That is, if you plug in these values into either one of these, it will work. Now, I think that it's a little bit easier to plug it into the green one than the purple one, but it doesn't really matter in the end. Both of these answers are perfectly correct. So I'll just use the green one. So 20 over 2 pi minus 4 squared. 20 minus over 2 pi minus 4 squared should equal h. So if I put that in my calculator, and I remember to put this in brackets, then I'm actually getting negative 12.8 as my answer to the nearest tenth. So we will do this one where we're isolating for s. So we can subtract this from both sides, try and make that go away. So we have a minus pi r squared is equal to pi r s, and then we can divide both sides by pi r. So s is equal to a minus pi r squared over pi r. And then we want to figure out what s is if they've given us a 10 minus pi 5 squared over pi of 5. So there's a few tricks here if you want to type this in your calculator. You need to put the top in brackets and the bottom in brackets, because if there's multiple things going on in the top and multiple things going on in the bottom, you need to make sure you keep the top together and the bottom together. Otherwise, you're going to get the incorrect answer. Now, my preference is to type in everything from the top first and then hit enter and then divide by the bottom in brackets. If you do this correctly and you round it to the nearest hundredth, you're going to get negative 4.36. So the situation is we are supposed to use 250 grams of flour. And we are supposed to use 75 grams of sugar. So here is the conversion factor that we're going to be using. But I only have 70 grams of sugar. So I'll have to use less flour in order to just make less stuff. So how do we set this up? So we want to know 70 grams of sugar is how much grams of flour, and that is our x. So we can do this using a method called proportional reasoning. So if we want to find x, the first thing to keep in mind is when you're finding x, it's much easier to find x when x is in the top. So we can put x in the top here. So x grams of flour and 70 grams of sugar. That is going to be a proportion. And that proportion, we want it to be the same as this blue proportion that I have put here. I guess technically I should have put this in red. So I'll rewrite this in red. So the red proportion, which is the mystery one, x grams of flour, 70 grams of sugar. And then the blue proportion, we want the fraction of those things to be the same. So you have to make sure that when you set this up, though, you want to put the flour in the top and the sugar in the bottom, because that's what you did in the red. So you have to do the same thing in the blue. So 250 grams of flour over 75 grams of sugar. It should, in theory, be the same proportion. Okay? Now, this is very difficult to solve because of all the units in it. So I'm just going to make it a little bit clearer by deleting all the units. I know that I have set this up correctly because flour's in the top, sugar's in the bottom. X over 70 is equal to 250 over 75. Should be the same proportion. So then in order to solve for x, we can multiply both sides by 70. and we can calculate that out. So 250 times 70 divided by 75, and I'm getting x is 233 repeating. So if this was a real recipe, I would say round to the nearest gram is close enough. So 233 grams. So the key to solving these proportional reasoning questions is you have the proportion that you know in blue and then your mystery proportion in red, and then you want to set those equal to each other. Now, would it have been correct if I were to put the sugar in the top and the flour in the bottom? So if I wanted to put 70 grams of sugar in the top, X grams of flour in the bottom, and then of course we would put the flour in the bottom here and the sugar in the top. This is perfectly acceptable. You can do it that way so long as there's the same units in the top and the same units in the bottom. It's just that this makes it a little bit harder to solve because now X is in the bottom, and that's a little bit annoying. So if you're clever about this, you'll set it up and put X in the top intentionally. Normally takes Jen 45 minutes to decorate 60 cupcakes. How many can she decorate in 100 minutes? So we need to set up our proportions. We know that 45 minutes, you give her 45 minutes, she'll get you 60 cupcakes done. But how many can she decorate in 100 minutes? So we're going to set this up with X cupcakes and 100 minutes. And we're going to set that equal to 60 cupcakes in 45 minutes. And to make this a little bit cleaner so that I can solve it, X over 100 is equal to 60 over 45. Then I multiply both sides by 100 to get X by itself. And let's see. And X is 133.33, but I would say that we round to the nearest cupcake, and we are decorating 133 cupcakes in 100 minutes. This is proportional reasoning, and you can use it to convert units as well.